Welcome back, everybody. This is our fourth session in JEE Mains previous year questions for chapter Ray Optics and Optical Instruments for class 12th. Before this video, we have made 3 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET, and if some of your friends are preparing for that, then you can guide them through those videos. Also, if you like to support us by sharing these videos and subscribing to our channel, and you can do financial donations also by scanning the QR codes in front of your screen. With this, let's start today's video. In the previous one, we covered up to, I think, question number 30 or something. Yes. This was one of the last questions which we covered. And today we will start with the next one. So here, as mentioned, a beaker contains water up to height h1 and kerosene at height h2. Let me adjust pen thickness first. So that the total height of the kerosene, water plus kerosene is h1 plus h2. Refractive index of the water is mu1 and that of kerosene is mu2. Apparent shift in the position of the bottom of the beaker when viewed from the above. So the assumption we are going to make here that we are dealing with small angles. That's the assumption we are using. So we know that d apparent is equal to d actual divided by refractive index, and here we have two heights and two refractive indexes. So total d apparent will be equal to h1 by mu1 plus h2 by mu2. That is the apparent length, and actual length d actual will be h1 plus h2. So shift will be, that will be suppose delta d, that will be d actual minus d apparent. So it will be h1 minus h1 by mu1 plus h2 minus h2 by mu2. And this will be h1 common 1 by 1 minus 1 by mu1, and plus here we will have 1 minus 1 by mu2 h2 common. That matches with option D. Let us move ahead. A transparent solid cylinder rod has a refractive index of 2 by root 3. It is surrounding by air. A light of ray incident at the midpoint of the one end of the rod as shown in the figure. The incident angle for which the light ray grazes along the wall of the rod. So here the light is grazing across the wall of the rod, means what is happening here, where we have total internal reflection. So for that we have that sine of theta c is equal to 1 by mu, that is the condition for TIR. So here sine theta c will be equal to 1 by mu is 2 by root 3 here, so that will become root 3 by 2, and theta c will be sine inverse root 3 by 2. That matches with option A. Now let's move to the next one. Here, a fish looking up through a water sees an outside world contained in a circular horizon. If the refractive index of the water is 4 by 3, fish is 12 centimeter below the surface, the radius of the circle in centimeter will be. So the fish will be able to see through a cone, and let me show you how it will look like. Here it is. Here, this is a cone, and rotate it. And now let us add a tank, water tank. So suppose this pink color represents the water tank, and this point we have fish. Our fish is here, and it is able to see only through these lines. Why? Because if the light across light coming from this, suppose some light is coming from here, then it will go like this. It will not reach the fish. Or basically, if we reverse the condition here, that if fish has a suppose some torch, and if he lights the torch with angle theta with the vertical, then after certain value of theta, light will graze through this surface like this, means total internal reflection will happen. So here we have a critical value of theta beyond which light cannot go out and outside light cannot come inside. So for that, for critical angle, we can write that sine of theta c will be equal to 1 by mu, and that will be 1 by 4 by 3, or basically 3 by 4. Now, uh, we have a triangle like this. If this is theta c, so this is 3, this is 4, so this will be root 7. Now, what we can do here, if we make a triangle like this, a triangle OAB. In this triangle, we know this OB is equal to distance of the fish, that is 12 centimeter, and we have to find OA, that is the radius here. So R by OB means R by 12 will be equal to perpendicular by base, means tangent of theta c, or tangent of theta c from this will be equal to 3 by root 7, and from this radius will be 36 by root 7. That is option A here. Let us move ahead. Consider the telecommunication through optical fibers. Which of the following statement is not true? Optical fibers can be graded of refractive index. Optical fibers are subject to electromagnetic interference from the outside. Optical fiber have extremely low transmission loss. Optical fibers may have homogeneous core with a suitable cladding. The option wrong is here, that is optical fiber have extremely, we can say, non-susceptible to the noises outside. And what type of noises I'm talking about? I'm talking about electrical noises. So in optical fiber, we don't have the problem of electrical noises or outside noises, and that is option B. That is wrong here, and we have to find not true. So option B will be the right one. Now, which of the following is used in optical fiber? That is total internal reflection. So option A is right. Now let us start the next one. A point-like object is placed in front of a distance 1 meter in front of a convex lens. Focal length 0.5 meter. A plane mirror placed at a distance 2 meter behind the lens. The position and the nature of the final image. So let me slide it slightly to make the proper space. Now, suppose this is our convex lens. This is our convex lens, and this is the principal axis here along which we are dealing. Now we have a mirror. Here, this is our mirror. And this is the reflecting side like this. So what will happen here? That suppose if we have some object, suppose we have some object here, then uh, this lens will form an image of this object here. Suppose this is the image formed. Now this mirror will again form a image of this object, of this image. Let me draw the ray diagram so that it can become slightly more, I can say, better understanding. So a light ray will go like this, they will bend like this, and they will go like this. Now after this, they will go like this, and they will now further continue like this. Now what will happen, that this was the actual object. Now this was the image by lens. Now this is the image of image by mirror. This is the image of this image which is produced by the lens. And now this image will act as an object for this lens. And what we will get? We will get final object or final image somewhere here. So suppose this is the final image. And we have to find out the position and nature of the final image from the system. So we have to find out that what will be the nature of this image and other criteria, that what will be the distance of this image. Now let us start with the lens first. For this lens, what we will have? We will have 1 by v minus 1 by u is equal to 1 by f. So from this, 1 by v will be equal to 1 by f plus 1 by u. Here u will be negative, and focal length, as we are hitting on this side, so focal length will also be positive. So it will be 1 by 0.5 plus 1 by value of u is 1. U will be negative here because distance the object is here, so it is minus 1. So what will be? It will be 1 by v is equal to, this will be 2 minus 1. So basically v will be equal to 1 by 1 or 1 means, and this is positive means image is formed on the we can say right hand side. So this is 1 meter. Now this is also 1 meter. So now coming to the that, and mirror is placed at distance 2 meter behind the lens. So this distance is 2 meter here. Now we have calculated at this is 1 meter, so this is 1 meter left. Now for a mirror, image is formed at exact distance of the object. So if this is 1 meter, then this is also 1 meter. So now total distance of this image by the mirror from the lens, which will act as a object distance, this will be equal to 3 meter. So now we can again solve this one, that now we will again apply the lens formula, that 1 by v minus 1 by u is equal to 1 by f. Again, this was the first image by lens, and this will be the second image by lens. So now we will calculate. So 1 by v is equal to 1 by f plus 1 by u. Now f, as we are striking light from this side, now it is hitting on this surface, and this surface has radius on this hair. So it will be hair focal length will be negative. So it will be 1 by negative 0.5 plus 1 by u, as u now object is on the right side, so u will be positive, so this will be 1 by 3. So this will be negative 2 plus 1 by 3, and this will give us negative 5 by 3. And finally v will be equal to 3 minus 3 by 5. And if we solve this, this is negative 0.6. And what are our units? Our units are meter. So this will be negative 0.6 meter means, and it is negative, so final image is formed on the left hand side. So this image is not here. This image is this image is somewhere here, because our initial object was 1 meter apart. So this is the final image, and it is at 0.6 meter from the lens. Now let us see the given options. So in all of the options we have give distance from the mirror. Now from mirror it will be, as this is already 2 meter, and this is 0.6 meter. So total distance of the final image will be 2.6 meter. So option B and C are rejected, and we have to find out that whether it will be. Now we know to find the means whether it will be real image or a virtual image, but we can assume we assume it as a normal object. This image, this object, which was a virtual, and this is acting as object for this lens, we consider it as a normal object. Now it is placed at for this lens, focal length is 0.5 meter, so it is beyond. It is placed beyond f. And in case of convex lens, if object is beyond f, means not between pole and the f, but beyond f, then its image is always real. So here final image will also be real. So option A will be the right answer and D will be the wrong one here. Let us move ahead. A double convex lens has a power P and same radii of curvature f r of both of the surfaces. If the radius of curvature of a surface of a plano-convex lens made of the same material with power 1.5 p is. So here we have to compare two type of lenses. One is the normal lens and another is the plano-convex lens. So using the lens formula, lens maker's formula, we have 1 by f is equal to mu minus 1 by r1 minus 1 by r2. And here we have same radii, so r1 equal to r2 in magnitude equals to r. And for a double convex lens, our this side has a positive curvature and this side has a radius negative curvature. This is r1 and this is r2. So for the normal lens, we will have 1 by f is also known as power. So power will be mu minus 1 and here we will get 2 by r. Now for the plano convex lens, suppose that is 1 by f dash, that will be plano convex lens will be like this. This is planar side and this is convex side. So this will be mu minus 1 as refractive index is same, material is same. 1 by r1 is infinite as this is a planar side minus 1 by negative of r and this will be mu minus 1 by r and this is p dash. So this can be written as twice of means 1 by 2 of twice mu minus 1 into r or divided by r, and that is the original power. So this will be basically p by 2. Oh, sorry, I thought that we have to compare their powers, but actually it is that we have been given power for plano convex lens and we have to find this radius of curvature. So what we can do here, let me solve it in a separate. So 1 by f dash, here it is given to be 1.5 times of p will be equal to mu minus 1 into 1 by infinity minus negative of r dash, assuming its radius of curvature of this side is negative r dash. So 1.5 times p, here where we have value of p, so 1.5 will be 3 by 2 into mu minus 1 divided by r into 2 is equal to mu minus 1 divided by r dash. So mu minus 1 gets cancelled, 2 is cancelled and r dash will be from here r by 3. That is option D here. So option D is the right answer. Let us move to next one. For a concave lens, the focal length f, the relation between the object and image distance uv respectively from the pole can be best represented by u is equal to v is a reference line. So we have to represent it with respect to u is equal to v here. So if we can see that this is the u is equal to v reference line. So for that, let us start with the lens formula, that 1 by v is equal to 1 by u plus 1 by f. And from this we can find relation for v, that v is equal to fu by f plus u. Now we know the conditions that let us start with v is equal to u. If we have v is equal to, oh sorry, oh yes, if we start with v is equal to u condition, so that is our case one. So we will have fu is equal, u is equal to fu by f plus u. U is cancelled, and from this we will get f is equal to f plus u. So for that scenario, what we will have, as f is not 0 means u is equal to 0. So if u is 0, v is also 0. Now moving ahead, now suppose if second case, if u is infinite. So if u is infinite, we know that if object as infinite, then v is equal to f. So when we increase the value of u in any graph, when we increase the value of u in any graph, the value of v must saturate to f. And here we can see that in option D, here we are not going to infinite. So option D is rejected. In case of option B also, we are not going up to infinite, and so option D is also rejected. Now let us take a point where we can say uh, third point where u is equal to f. So if u is equal to f, then we will have v is equal to f square by 2f, and from that v is equal to f square by 2f, that will give us f by 2. And if we apply this criteria here, so in option, we can say, in option C, here we can assume that if u is equal to f, then it might be f by 2. And similarly in option A also, same condition holds. Now we have to find out that what type of behavior of the graph will show from between A and C. In graph A, we can see that v is either equal to u or it is less than equal to u. And in case of graph C, here v is sometime uh, going beyond this u is equal to v line. So let us, for that to find this behavior, let us take u is equal to x times f, where x varies between uh, we can say 0 to 1. So from this formula, then v will be equal to x f square divided by f common into x plus 1. So it will be xf divided by x plus 1. And from this, we know that this term is x into x by x plus 1. So this will be always less than 1. So from this, v will be always less than, we can say, x of f. So when u is equal to xf, then v is always less than xf. So means we will stay below the u is equal to v line, and that behavior is shown here. So option A will be the right answer for this one. Let us move ahead. So here the distance between object and screen is 100 centimeter. A lens can produce real images of the object on the screen for a two different position between screen and the object. The distance between the two positions is 40 centimeter. If the power of the lens is close to n by 100 diopter, then n is integer. Find the value of n. So this question is basically related to displacement method. So it can be solved using the direct formulas, and what we are doing here, we will solve it by normal method. So suppose here is our object. This is the first position of the lens, and this is the second position of the lens. And here we have the screen. Now it is mentioned that suppose this distance is x, and both of these positions are separated by a distance of 40 centimeters. So this distance will be 40, and this remaining distance will be equal to 100 minus 40 minus x, so that will be 60 minus x. So let's start with the first one. So for this lens, we can write using lens formula that 1 by v plus 1 by u is equal to 1 by f. Oh, sorry, we will have negative here. So for the first lens, u is negative of x. So we can write 1 by, and v will be 60 plus 40 plus 60 minus x. So that will be 100 minus x. So that will be 1 by 100 minus x plus 1 by x is equal to 1 by f. Now this is for the first lens. For the second lens, u will be 40 plus x and v will be 60 minus x. So 1 by 60 minus x plus 1 by 40 plus x is equal to 1 by f. Now both of these sides are equal. So let's take LCM of this one. So from this we will get x into 100 minus x divided by here x plus 100 minus x should be equal to 60 minus x into 40 plus x. Here we will have 40 plus x plus 60 minus x, and when we solve this we will get x is equal to 30 centimeter. Now when x is 30 centimeter, now we can use the formula, this one, that 1 by f will be equal to 1 by 100 minus x, yani 1 by 70 plus 1 by 30. And when we solve it for focal length, then focal length comes out to be 21 into 10 raised to power minus 2 meter, because all actually comes out to 21 centimeter, and converting it into meter, and from that power comes out to be, that will be 1 by f. So that will be 100 by 21, and that will give us 4.76, and we have to represent it n by 100, so n will be equal to 476. So answer here will be 476. Now let us move to the next one. A point object in air is in front of a curved surface of a plano-convex lens. The radius of curvature of the curved surface is 30 centimeter. Refractive index of the lens material 1.5. Focal length of the lens we have to find out. So we can use lens maker's formula that 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. Here one of the radius will be infinite. So here we have the refractive index 1.5, so it will be 0.5 over 1 by 2, assuming r1 to be infinite, so 1 by infinite negative and r2 be negative, so minus of negative 30, and this will give us 1 by 60 centimeter. So focal length will be 60 centimeter here. It can be either positive or negative depending upon the shape we take. Now let us move ahead. A thin lens made of glass of refractive index 1.5 or focal length 16 centimeter immersed in a liquid of refractive index 1.42. The focal length of the liquid is FL, then the ratio of FL is close to the integer. So here FL is the focal length inside the liquid. So normally what we have, normally we have lens maker's formula from, and we are taking in centimeters. So 1 by 16 will be equal to 1.5 minus 1, that will be 0.5, and that will give us 5 by 10 into 1 by r1 minus 1 by r2. Now inside the liquid what will happen, that suppose inside the liquid focal length is f, and that will be equal to 1 minus 1.5 divided by 1.542. Oh sorry, reverse will happen. It is mu minus 1, not 1 minus mu. So that will be 1.5 by 1.42 minus 1 refractive index of the lens by the liquid into 1 by r1 minus 1 by r2. Now what we can do, we can divide both of these equations, and from that we will get that f by 60 is equal to 0.5, that is this term, and solving this we will get 0.08 by 1.5, and from this f will be equal to, or as we have to find out ratio, so ratio will be like ratio will be this, so this will be we will have zero point 0.5 as 5 by 10, this 1.5 will go above, so that will be 15 by 10, and here you will have 8 by 100. So these are cancelled, and we have to find out closest to the integer. So what we will do, we will do assumption here, approximation. We will assume that 15 as 16, so this will be 5 into 16 by 2, so this will be 10. So the option that matches, that is nearest to us, that is 9. So option B will be the right answer. So with this, we end this video here. Hopefully whatever we have covered is helpful to you. Again, if you have any doubts or suggestions, you can put them in comment section. I will try to resolve them. And if you like this video and want to support us, then you can scan and donate any amount. With this, again, thanks for watching, and we will meet in next video.